Hello everyone, welcome back to my YouTube channel. In this video, we are going to discuss on X-ray diffraction on the topic of determination of incident light wavelength. In a sample exhibiting a cubic lattice structure with lattice constant of 4.0 times 10 to the power of negative 10 beta, predict the wavelength of the incident radiation that corresponds to diffraction from the 532 plane, given that the angle of incidence represented as 2 theta is equivalent to 28 degrees. So to answer this question, the first thing that we need to do is we need to identify what are the information given to us. So we know that the plane is 532 and the 2 theta is equivalent to 28 degrees and the lattice constant is 4.0 times 10 to the power of negative 10. So what we can use now is we need to find the D spacing is equivalent to the lattice constant, which is 4.0 times 10 to the power of negative 10 beta, divided by the square root of your HKL, so H 5 square plus 3 square plus 2 square. So your D is equivalent to 4.0 times 10 to the power of negative 10 meter, divided by the square root of 38. So from there you will get your D is equivalent to 6.4889 times 10 to the power of negative 11 meter. So in the question, you were asked to predict the wavelength of the incident radiation. So in order for you to find what is the wavelength, you need to use the Bragg's law. So n lambda is equivalent to 2d sine theta. Alright, so from our calculation just now, your D is equivalent to 6.4889 times 10 to the power of negative 11 meter. So in the question, it doesn't state any of the order. So we assume your n is equivalent to 1 and you are trying to find what is lambda. So next up, in the question, it states here 2 theta is equivalent to 28. Therefore, your theta is equivalent to 28 divided by 2, equivalent to 14. Alright, so now we are just going to finish up this part. So 2d sine theta, so your theta is 14. Therefore, you will get your lambda is equivalent to 2d. So your d is 6.4889 times 10 to the power of negative 11 sine 14. So you will get your lambda is equivalent to 3.3197 times 10 to the power of negative 11 meter. So this is the final answer for this question. Thank you so much for watching this video from the beginning till the end. I'll see you again in the next video. Goodbye.